Hello there, and then welcome to a brand new lesson. I do hope you are doing well. In this lesson, we are looking at simplification of sets, and we would focus on the product rule. So, without much ado, let's quickly look into it. Now, the product rule is used to simplify what? Radicals. By simplifying, I mean if you have the square root of any radical at all, x, right? You want to write it as a form a root b. Now, how do we do that? The product rule makes us understand that if you have a radicand, you see, if you have a radicand, that can be written as the product of two numbers, a and then b, then it simply means that you can express the radical sign for both factors. You see, so you can express that the square root of a times the square root of b. You see, and the inverse is also true. That simply means if you have the square root of a and then the square root of b, we can rewrite them as the square root of the product of a and then b. This rule allows us to separate a radicand into two factors, one of which must be the largest perfect square of the radicand. Now, the theory is actually too much. So let's just take some examples and then we see what this rule actually does. So for our very first example, we have to simplify the said root 75. Root 75. So solution. Now, as I solve the solution, we'll be using a series of steps. So you need to take note of them and then you can also solve some. We have the square root of what? 75. So the first thing you need to do to be able to simplify this is to identify the largest perfect square. That is a factor of 75. Identify the largest perfect square. That is a factor of 10. When we say perfect square, we mean the numbers that when we find their square root, we actually get counting numbers or rational numbers. For instance, we have 4. So 4 is a perfect square. You have 9 also being a perfect square. And then we have 16. We have 25. How am I getting them? So 2 times 2 gives us 4. 3 times 3, 9. 4 times 4, 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. Then 8 times 8 we have 64. Then 9 times 9 we have 81. And then 10 times 10 we have 100. You should know a handful of them, right? So with this one, I think we are good to go. So what we want to do is we want to identify which of these perfect squares is a factor of our 75. For that matter, take the biggest one. Okay. So looking at it closely, you realize that 25 here is a factor of 75. So after you have been able to identify that, what you do is you rewrite your said. So 75, you are going to rewrite it as the square root of 25. 25 times what gives us the 75 times 3. You see? So you write it this way. Now, what does the product rule say? It says if we have something like this, that is of this form, the first one can take the said expression or the radical sign, and then the second one can also take the radical sign. So let's apply that here. So applying that, we are going to get the square root of 25 times the square root of what? 3. You see? So we are making progress. Now that we have the square root of 25 times the square root of 3, we now do what? We have actually split the set, right? So we take the root. That means we should simplify the root of the perfect square. You see, this one here, you should simplify it. And then leave this one because this cannot be simplified. It will give us an irrational number. So this simply means the square root of 75 now becomes, we know the square root of 25 to be what? 5. So it's a 5 times square root of 3. And since there's no way we are going to simplify this, our final answer is actually going to be 5 root 3. Right? This is our final answer here. Very, very simple. So let's go over the steps again. If you have a said expression you want to simplify, all you need to do is identify the perfect root, especially the biggest one that is a factor of your said expression here. With this, we realize that we had what? 25. 25 was that number. 25 times what gives us 75. So you come and write that here, or under your expression or your radical sign. Then now you take them one after the other. So we have square root of 25 and then the square root of 3 as well. Then you evaluate that which is a perfect square. And as we have done here, that gives us a 5. This isn't going to be evaluated because it is irrational. That is a set. We have 5 times root 3. Let's pick some few more examples so we see. Okay, so in this next question here, we are to evaluate the said root of 32. If you have been able to grasp the understanding with respect to the first video or the first example, you can do this on your own. So you come in and check. But let's do it together. So we have the square root of 32. You see, and we say the first step is to identify a perfect square whose factor is what we have here. The perfect squares we have, let me say, we have 4 and then 16. But we said we should always take the biggest one. So if we take the biggest one, I would actually do that with the biggest one. If I finish, I'll take the small one, which is 4, and then we'll see what is going to happen. So the square root of 32 now becomes the square root of 16 times 2. See, and the law says if you have been able to write it this way, then let's separate them. So that we have the square root of 16 times the square root of 2. You see, the square root of 16 we know gives us a 4. So we have 4 times the square root of 2. And 4 times square root of 2 now gives us 4 root 2. Very simple, right? Straightforward. Now, if you decided to take the 4 mistakenly, you're going to get the square root of 32 being equal to the square root of 4 times 4 times your what? We know 4 times 4 times 2 will give us the 32, right? That is if you decided to use a smaller one. So it just simply means instead of 2 numbers here, you are going to get 3 numbers here. But that isn't a problem. The most important thing is you apply the rules. So this time around, since we are having 3 numbers, then it's going to be the square root of 4 times the square root of 4, then times the square root of 2. And we do know that the square root of 4 here, that is this first one, will give us a 2. Times the square root of this 4 also gives us a 2. Then we have the root of 2. So 2 times 2 gives us a 4. And then the 4 times the square root of what? 2. Which gives us 4 root 2. Then as you can see, we have actually arrived at the same answer. So any method works. But for a quicker way, just take the biggest perfect square, which is the factor of the radicand you have over here. Now, this is how far this lesson is going to go. As usual, I'll leave an exercise for you to try on your own. So you have the question here which says you have to simplify the following. The first one says root of 24. The next one, root of 44. You have root of 80. You have root of 128. And then the root of 180. If there's any issue of concern, you can always let me know at the comment section, and then I'll address that for you. You can also re-watch the video so that you become used to it. If this is your first time, you can always choose to subscribe so that anytime I release the next video, you'll be notified as well. See you in our next lesson. Bye for now.